All right, here's Precalculus Concept 1B sequences using recursive formulas. There are 3 boxes. Let's get right into it. So the first word that we're going to be talking about today is learning how to define a sequence using recursion or a recursively defined sequence. So let me explain to you what recursively defined sequence means. Let's say I tell you that a sequence begins with the number 4. So the very first term is the number 4. And I'm going to tell you that the way that you build the sequence is simply by taking the previous term, multiplying it by 2, and then subtracting 1. Okay, so if I'm going to write out the first 4 terms like this, it'd be something like this. Okay, the first term is 4. I said that the next term is the previous term times 2 and then subtract 1. So in order to get this term here, I would go 2 times the previous term, which would be 4, and then subtract 1. So 2 times 4 is 8. And 8 minus 1, of course, is 7. Okay, good. Now to get the next term, I would take the previous term, which in this case is 7. So I would go 2 times 7 and then subtract 1. So that's 14 minus 1 would be 13. To get this term, the fourth term, I take the previous term, which happens to be 13. So 2 times 13, then minus 1. So that's 26 minus 1 is 25. So in order to get this term, right, I have to know something about the previous term. That's the basic idea for recursively defined sequences. You have to, in order to get the next term in the sequence, you have to know something about the term right before it. So example, right? If I want to know the 5th term, I have to know the 4th term. If I wanted to know the 4th term, I had to know the 3rd. That's what it means for a sequence to be defined recursively. Okay, box number 2 is all about the notation with an example here. So let's say I have a sequence that goes 3, 6, 9, and then dot, 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 and then it moves up in the sequence. So this is the very first term. So a sub 1, this is a sub 2, this is a sub 3, and then we have dot, 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 dot. Okay, so if this term right here, let's call this term a sub n, right? If I call that one a sub n, how would I define the term right before it? It would be defined as a sub n minus 1. I hope that makes sense, right? How would I define the term right to the right of it? Well, that would just be a sub n plus 1, right? Think about it. If I have a sub 2 here, then the term right before it is a sub 2 minus 1, which is a sub 1. And the term right after it is a sub 2 plus 1, which would be a sub 3. So if you're given any sequence or any term in the sequence a sub n, the one right after it is a sub n plus 1, and the one right before it is a sub n minus 1. Now we need that in order to understand how to do this next example right here. So let's say, for an example, I say that the very first term is 5, and the next term in the sequence is defined as 3 times the previous term and then add 2. Okay, so 3 times the previous term and then add 2. And the directions say write the first 4 terms for every n that's greater than or equal to 2. That just means that we're starting at the number 2. So let's write it out. Okay, I want a sub 1, I want a sub 2, I want a sub 3, and I want a sub 4. It says write the first 4 terms. Well, it already gave me the very first term is 5, so I know that one's 5. Then it says here, the next term in the sequence is equal to 3 times the previous term plus 2. So this has to be 3 times the previous term, which would be 3 times 5, 15 plus 2 makes 17. That's how I got that one right there, okay? To get this term, I go 3 times the previous term and then add 3. So 3 times 17 plus 3 is 53. All right, how do I get the 4th term? I go 3 times 50, I go 3 times 54, and then I add 2. I should end up with 161. So make sure you check my math, that looks good. So that's a recursively defined sequence. All right, third box says, here's another example. Let's write the first 4 terms for this recursively defined sequence. And starting with the first term is 3. So a sub 1, here's a sub 2, here's a sub 3, here's a sub 4. Okay, it gave us the first term is 3 because it defined it for us. It says a sub 1 is worth 3. Then it says the next term in the sequence is equal to 2 times the previous term and then plus 5. So in order to get this one, I'm going to take 2 times the previous term, which is 3, and then I'm going to add 5. So that's going to be 2 times 3 is 6. That's going to give me 11. To get this term, I'm going to go 2 times the previous term, which is 11, and then add 5. So that's 22 and 5 make 27. To get this term, I'm going to go 2 times the previous term, which is 27, and then I'm going to add 5. And that ends up being the number 59. So the first 4 terms in the sequence are 3, 11, 27, and 59. And again, this is all what's known as a recursively defined sequence.